it's like a desk view here. That's why my hand is all distorted. Today we're gonna talk about savings and social security, and an overall summary of everything we've done. And I'm back. All right. So in this period, in this economy, there are two periods, and you get Y when you're young, none when you're old, which is normal. You're endowed with Y units, and the economy is growing. The population is growing, which also means the economy is growing. Whatever. So what does the and the main assumptions here is that you save when you're young, and that um, that amount that you saved gets paid out to the old when they're older, because they aren't given any Y. So the way that this economy functions is based off the pension that you save for while you're younger. So while you're young, your budget constraint is C1, how much you consume, plus ST, so how much you save, should equal the amount you've been endowed. So yeah, you consume some amount, the like one minus that, or like the leftover of that is however much you didn't consume, you save it. So now when you're older, so you're not given anything else, you just consume what you saved while you're younger. But whatever it is you saved, you multiply that by R, which is the interest rate. However much the economy has like however much the interest rate has grown over the generation. So if R just equals one, that is just the amount that you saved. But if it's more, then the saving that's been allocating interest, is what you'll be eating basically. So the lifetime budget constraint is C1 plus 1 over RC2 equals Y, which is similar to how we did the last one, which was 1 over N, C2 equals Y. So now that we know that, and I just want to highlight, because we we're talking here about the budget constraint, we're not talking about the resource constraint, and it's the lifetime budget constraint. We don't add the population numbers. Like, we don't do NTC1 plus NT minus 1 C2. We don't do that. That's for the resource constraint, and it kind of like I can elaborate later why. So that's the lifetime budget constraint. So the point of it is we want to see, when the government introduces the pay-as-you-go pension plan and actually starts to take away from the young and give to the old, we want to see how much the young is being taxed and how much benefit is going to the old, where the tax is, like taxed from their endowments, and the old is getting the benefit, which is the tax from the endowment. So how it would look like is, the young, it is the same. They consume some amount and then save to the side. And now the batch that they can consume and save from is smaller because it's been taxed by Tau, some amount. And then the old, gets the same that they save, plus B, which is benefits. So this just ensures that they have benefits when they're older. So we want to show how does this look like in the lifetime budget constraint, and how does this look like compared to the original before the tax and the benefit. So the budget constraint simply changes by which is the same C1 plus 1 over R C1, C2. This is supposed to be C2. Yeah, I realize this is very bad quality. This is very bad quality. Whatever. I'm explaining, so whatever. So how could I make this better? If I put like a flashlight, it's definitely better, but I look bad. And what matters more? You know what I mean? Okay, yeah. Now, so obviously, what changes here is the budget constraint now just subtracts tau and adds 1 over r benefit. So how does that look like when n is greater than r? So first, we want to see what the relationship is like, and how these things affect each other. So if you so you derive the lifetime budget constraint. Now we want to find the government's budget constraint because now they introduced a tax and benefit. So, like what it means is the benefit of the old has to equal the tax of the young. That's clearly the budget constraint. So we plug in the fact that the population is growing, and when we do that, we see that the benefit equals the population growing tau. Because remember how we said in the gift giving, where omega is it grows as the population grows because there are young people that tax more. So that there are more young people than old. So the benefits received is not just tau; it's the growth rate tau. So if you plug that back into the lifetime budget constraint, and after whatever, you get C1 plus 1 over or C2 equals Y plus B, and then in brackets, N minus R over Rn. So what this relationship now means, because we have N minus R right here, if N, population growth, is less than the interest rate that you're getting on saving, I apologize for the inconvenience. So back to what I was saying. So if the population growth is less than the interest rate, and here we have n is minus r, this number will be a negative, and now we'll be subtracting from the endowment, which will be decreasing the budget constraint from its original value. If it decreases the budget constraint, that means if n increases, that means it will increase the budget constraint, which tells us that if the growth of the population exceeds the amount that's being invested in the saving, so the interest rate, the government is able to allocate more funds. Their budget expands. The lifetime budget constraint expands, which means people now have a new indifference curve where consumption is higher on both ends for the young and the old. So for both individuals or both generations, it's better for the population growth to be higher than the interest rate, while it's worse. It's worse for both of them for the population to be slower than the rate of return. So yeah, that's that. I mean, that should be pretty like intuitive in that sense, but like to kind of explain it further, a growing population means there's more young than old. And if there's more young than old, because the young people are the ones that are producing and the old are consuming, there's now more production that is being consumed. Meaning, like from a cost revenue standpoint, there's just more profit. There's less cost to the revenue that's being made, which means that there's more benefit for the tau that is being put in. The benefit increases in that sense. But if the population is growing less than the rate of return, that means it's a slower population. There's less young population than old. That means there's less productivity and more people, eating the productivity. Which means there's less benefit for the amount of tau that is going in. It's still more because say the population growth is 1.5, but the rate of return is 1.2. You're still getting 20% more from the last generation, but you could have been getting 50% more. So yeah, think of it as like literally just like a rate of return that is less. But here, the population acts as if it's its own rate. So now, how about this? What if the population does grow faster than the rate of return? So n is greater than r, but tau is greater than savings. So what that means is you are being taxed more than you can save, or more than you are currently saving, or at the current savings rate. So something I forgot to mention, but in this economy, there's no borrowing. So you can't, go to the bank and take out a loan. So what this is going to mean is this new budget constraint, which you can barely see because the lighting is bad and everything is still bad. Okay, if my shadow, okay, I'm just going to do this from now on every time I want to show you something. Yeah, this is much better. Okay. So the the budget constraint here shows this is just in effect. I'm just gonna put my head, a big head's gonna cover the the budget constraint is gonna decrease, although the population increased. Why does that happen? Because we are taxing more than being saved. This line here with the dots shows you what could have happened if we can borrow. So let me just fully explain what's happening here. So the population increased. Okay, so now we get a new budget constraint that's higher. So now the indifference curve is supposed to fall on, it's supposed to increase to this higher budget constraint. But what actually ends up happening is the budget constraint is cut off by the consumption point where y minus tau is greater than the consumption. The amount that is being taxed from the endowment has now got to a point where you can't consume anymore. So your consumption has like a stop that's here, and this means that, you know, at this point you could maybe consume more than here, but you're as an individual may or the young person actually starves. So then the old person can benefit, you know, which is wrong. And these show you that if you were able to borrow, if you're able to take out a loan, you would actually be better off. And the way that would go is, say in this economy you have benefits that's owed to you while you're older. You can take out a loan against the benefits that you're going to have, the like projected benefits, and that loan would give you enough cash to consume, or enough, you know, goods. Say there's no cash or whatever, would offset this problem. So then if you're able to borrow, if you're able to take out a loan, you would fall on the budget constraint that's higher here, and then you would be able to consume more. So the moral of the story here is that when economists and like policymakers are, you know, laying down these pay-as-you-go pension plans, or just pension plans in general, they need to make sure of two things. They always need to make sure that the increase of the population has to be more than the rate of return. And if that's not the case, then you have to make sure, well, that has to be the case, but you also have to make sure that the amount that's going into the pension plan cannot exceed more than a person's savings. Because if it does exceed a person's savings, they might actually be worse off. And if they're worse off, then it's not exactly a reliable, you know, pension plan. So, although it benefits the old, it just doesn't benefit the young and makes them borderline, like, you know, starve. So yeah, so that means when doing a pay-as-you-go pension plan, you have to make sure that the rate that the population is growing is higher than the rate of return on your saving, like the interest rate. And you have to make sure that your savings amount is always larger than the amount that you're being taxed. That's that. Now I want to talk about if the government is rolling over debt, how does that affect generations? So let's assume there is an initial old rich population, we'll call them N0, an initial level of debt, we'll call that B0. So, you know, the population grows and grows t plus 1, t plus 2, t plus whatever. And we want to model under what conditions does the government's time path of debt issuance become infeasible? At what point can they just no longer issue debt payments? So the population of the economy is going to have to deal with the debt that's being paid. And we're talking about the rich economy because they're the rich people, because they're the ones that are going to be taxed. So, or they're going to be taxed the highest or whatever. So how we model it is total endowment of rich young people has to equal the growth rate times the initial population of young people times that endowment. So you're just essentially getting the endowment of young people from the previous period has to be n times more, because it's how much the growth rates, the growth grows. So to model it as an actual, like, you know, plug-in function, it's nt times y, so whatever t is times the total endowment, equals n to the power of t initial n times y. So the exact same thing happens with debt, and debt grows at a rate of x. So B1 is, you know, the debt in period 1. that equals x times the initial debt, the period zero, basically. So the way to structure that is bt equals x to the power of t b0, which is um, just like, yeah, whatever it is, however much the x has grown over the years. So now that we're working with exponents, a way to, we would then graph it over time is we have to take the natural log of the expression. So to take the natural log of the total endowment of rich young people, first we do ln, the natural log of the total endowments equals uh, the time period times the natural log of n plus the natural log of initial n times y, which is the initial endowment or amount of endowment. And we do the same um, with b, with debt, sorry. So now when we graph it, we can see that because x grows at a faster rate than n, the uh, the interest that the debt is collecting is growing faster than the population is growing. So at some point, there's going to be some intersection point, which is here, which is period t, where debt is going to be more than the growth of debt is going to be more than the growth of the population. The growth of the interest on debt will be more than the growth of the interest on the population. And that point is where it becomes infeasible. So anytime before that, the population is more than n. It is increasing, but at a decreasing rate than x. At the point where x surpasses it, at that point, it's not feasible anymore for the population to be issued debt payments. It would be not feasible for the economy. So it has to make sure it never exceeds t, or big T. So that's what rolling over debt is, and kind of like what the limitations of the government are. So now let's talk about the Lucas model. And to talk about the Lucas model, we have to talk about the Phillips curve. So the first question asks, why may we observe a negative correlation between unemployment rate and inflation? So the negative correlation between unemployment rate and inflation is the Phillips curve. And the Phillips curve used to be an effective way to measure the correlation between inflation and unemployment, where when there's high inflation, there's low unemployment, and when there's low inflation, there's high unemployment. So what the government used to do, or not usually, like this is something a government would do, is it would control how much output is in the economy by printing money. So say the output of an economy is not as much as where the government thinks it needs to be, they would create inflation by printing money. So then the people of the economy think that their product is now more sought out for just because the price increased. So they employ more people and then create more output. But in reality, it's just inflation. So this model obviously it's based on trapping people basically. So it's not a way to control output, and the government would use it in a way where when they need more output, they just print more money. Obviously, that's incorrect, and that's what Lucas proved. The Lucas model basically tells us no. If you if the economy is at a state of inflation, if the economy is at a state of high unemployment, printing money does not help. Because all printing money is going to do is the people are going to know they're at an inflation because they have, information, and the workers are not going to work harder, and there's not going to be more employment because people know it's just inflation. They're not being tricked into thinking that their product is more sought out for, or that there's some amount of demand that supply has to catch up to. So they're gonna what's actually going to happen is the people that are employed are going to ask for a higher nominal income pay to offset the devaluation of money that their income is about to deal with, and it's actually going to be worse off for the firms. So what you get is high unemployment and high inflation, and if anything, the company the firm would now probably go bankrupt at a less amount of years, which will then lead to more unemployment. So the Lucas model tells us why that can't work. So why we observe that negative correlation is just because the producer is only looking at their price change. And when they look at the price change, they assume, oh, okay, if it's just supply and demand, and the demand is high, meaning the price is high, then we have to make supply catch up to it, and then we will, we will close the gap on the surplus. But on the shortage, because we have now a shortage from the amount that we're supplying to the demand that it's supposed to be at. But that's just not the case. That would be the case if there's just no information in an economy. So why the government shouldn't use this to conduct policy is because it's a policy like to print more if there's a lot of inflation. It's a policy that's used, that only works if people are being lied to. But because the government, at least now, has to, like the central bank has to publicly talk about how much they're printing. They say, next period we have to print 10% more money. Then the producers know there's going to be 10% more, inflation, and the currency that they currently have is going to be devalued by 10%. So they know it's not because there's high demand. They know it's just inflation. So they're not going to work harder. Like they're just going to have to deal with the inflation, which in some cases means cut costs, and it could mean increase unemployment. Back when the value of the dollar was connected to gold, the Phillips curve used to kind of make sense because there was a hard stop as to how much money can be devalued, because there is some level where gold is valued something, and the fiat currency is dependent on that commodity. So so the government would actually be able to print without people knowing, because they wouldn't have to announce the amount that they're printing, and therefore people would actually think that the demand for their product is increasing, so they would employ more. So the Phillips curve would work in that sense, but but it would still be wrong because it's actually still inflation. But ever since we dropped the gold standard, we are now seeing the sensitivity of printing a lot when there's high unemployment, because now the money is kind of just free balling. So now let's go to the last question, which is the fourth part. So the fourth part kind of puts everything that we've done together. It's an economy with inflation, so the money supply is growing over time, and the MRS is now X C2 over C1. The marginal rate of substitution has some X value to C2, to the consumption of C2 over C1. So how does that look like? So the resource constraint has nothing to do with the MRS, so it's just C1 plus C2 equals Y, because the population is normal. The population isn't growing. If the population was growing, it would be 1 over 2 C2, but it isn't, so it's just C2. The optimal allocation is the MRS equal to the slope of the resource constraint. You look at the resource constraint, the slope is 1 over 1, which would just be 1. That means that C1 can be expressed as C2x or XC2. So I just want to, for intuition, C1 equals XC2 means the consumption of the young will equal some positive amount times the consumption of the old, meaning the young are consuming more than the old. So we plug that into the resource constraint, and we can see that C2 equals Y over X plus 1. C2 over equals Y. C2 equals Y over X plus 1, or 1 over X plus 1 times Y, means that C1 equals XY over X plus 1. So now, introducing inflation, we can define this economy as the following. So the lifetime budget constraint is C1 plus the rate of return C2 equals Y plus the rate of return A. A is the transfer that the government gives. The money market clears at VTMT, the amount that they're printing, has to equal the young population's endowment minus how much they consume. That's when the demand of money meets the supply of money. And the government budget constraint is like the amount that's been transferred to the old has to equal the money that's been printed times 1 minus 1 over z, so it accounts for the inflation that's happened. And using these, you can express that C1 plus C2 equals Y. That's the resource constraint. So now, what if the inflation rate is 5 over 4? So 5 over 4, like 1.25, whatever, we now use that to calculate the consumption level of C1, consumption level of C2, and the endowment that's given to the transfer, which is A. So we start by finding out the rate of return. The rate of return is VTMT over VT plus 1 MT plus 1. And because MT equals Z MT plus 1, and MT plus 1 then equals ZMT, because it's the previous one, then here we can cancel out the like terms, and we show that the rate of return is the inflation rate. So now we do the marginal rate of substitution equals the slope of the budget constraint, not the resource constraint this time, which is Z. And you express it 1 over whatever the slope is, or whatever the value is, which will be 1 over Z. 1 over Z, with Z being 5 over 4, means it's 4 over 5. So we express it as x C2 over C1 equals 4 over 5, which means C1 equals 5 over 4 x C2. So you plug that back into the resource constraint, and you get C2 equals 4 over 5x2 plus 4 equals Y. It's not pretty, but whatever. I know the exam is just going to play around with like these numbers. And then that means C1 equals 5x over 5x plus 4 times Y. So I just want to highlight there that as we see here, C1 C1 is going to be greater than C2. The consumption for the young is going to be greater than the consumption of the old, because we can see it, the denominator is just clearly bigger. It's 5 times x, while in C2 it's just 4. Because like the intuition behind that is because the young know that there's going to be some inflation rate coming up, and they're going to lose the value of their money. They have no reason to save it, so they're going to consume more of the endowment that's been given to them, less than the amount that they would save and give over to the old. That means that the old consumes less, and the old has to deal with the inflation. The amount that's been given to them by the young is not as valued as it once were, so that's why they would consume less. So with C1 and C2, we can plug that into the lifetime budget constraint and solve for A to find out how much A is being transferred. And we find that A equals 4 over 20 plus 25x times Y. That's how much transfer is going. Now we want to show that C star, so the monetary level, the monetary equilibrium consumption of the young is greater than the optimal consumption of the young. So we show it by just expressing the inequality, and we plug in the values. X over x1 plus y is given from here. We just remove the y, and it's because the monetary equilibrium accounts for the inflation, while the optimal allocation does not account, because it doesn't have to account for inflation. And when we do account for inflation, we see that the consumption in C1 after inflation is introduced compared to when it wasn't, makes sense for people to want to consume more when they know their money is going to lose value, so they're not going to save it. While before, they would consume at a level where there isn't inflation, so it's moderate consumption. They would save it for when they're older. So yeah, that pretty much wraps it up, and that's monetary economics for you. All right, thank you.